Chiều dần buông tan trường anh đến để chờ năm thơ đi học ra. Thì ra em đang ngồi trên chiếc xe đạp của ai không phải anh như muốn tắt luôn không thật thật đầu. Vì trông thấy em đang cười đùa cùng ai khác. Nhưng trên giấy sách không tròn ai đó hai mình đã có cái gì đâu. Người ta duyên nhiều tiền cao to một phần hơn anh ôi rồi ôi chán hồ. Làm sao anh có thể biết cảm giác em lúc này. Chỉ anh mới thấy phút yêu đôi trong mắt em thơ ngày rất nhiều lần. Mỗi ngày bên em là hạnh phúc, sao anh kia không quan tâm.
Ride solo. Instead, they bond with other atoms. Now, bonds can form between atoms of the same element or atoms of different elements. You've probably imagined bonding as a tug of war. If one atom is really strong, it can pull one or more electrons off another atom. Then you end up with one negatively charged ion and one positively charged ion. And the attraction between these opposite charges is called an ionic bond. This is the kind of sharing where you just give away your toy to someone else and then never get it back. Table salt, sodium chloride, is held together by ionic bonds. Every atom of sodium gives up one electron to every atom of chlorine. Ions are formed, and those ions arrange themselves in a 3D grid called a lattice, in which every sodium ion is bonded to 6 chloride ions, and every chloride ion is bonded to 6 sodium ions. The chlorine atoms never give the sodium atoms their electrons back. Every atom of a pure, unbonded element is electrically neutral because it contains the same number of protons in the nucleus as it does electrons around the nucleus. And not all of those electrons are available for bonding. Only the outermost electrons, the ones in orbitals furthest from the nucleus, the ones with the most energy, only those participate in bonding. By the way, this applies to ionic bonding too. Remember sodium chloride? Well, the electron that sodium loses is the one furthest from its nucleus, and the orbital that electron occupies when it goes over to chlorine is also the one furthest from. Cut and dried. If one atom doesn't completely overwhelm the other, they can actually share each other's electrons. This is like a potluck, where you and a friend each bring a dish, and then both of you share both dishes. Each atom is attracted to the shared electrons in between them, and this attraction is called a covalent bond. The proteins and DNA in our bodies, for example, are held together largely by these covalent bonds. Some atoms can covalently bond with just one other atom, others with many more. The number of other atoms one atom can bond with depends on how its electrons are bonding. Carbon has 4 electrons that are free to bond. Nitrogen has 3, oxygen 2. So carbon is likely to form 4 bonds, nitrogen 3 and oxygen 2. Hydrogen only has 1 electron, so it can only form 1 bond. In some special cases, atoms can form more bonds than you'd expect, but they'd better have a really good reason to do so, or things tend to fly apart. Groups of atoms that share electrons covalently with each other are called molecules. They can be
An attractive force called a hydrogen bond can exist between certain molecules. These bonds are weaker than ionic or covalent bonds because it takes less energy to break these types of bonds. However, a large number of these bonds going on can exert a strong force. Hydrogen bonds are the result of an unequal charge distribution on a molecule. These molecules are said to be polar. If we look at a water molecule, we can see the oxygen atom shares electrons with 2 different hydrogen atoms. So, in total, this molecule has 10 protons, 8 from oxygen and 1 each from the hydrogen atoms, and a total of 10 electrons, 2 shared between the oxygen atom and hydrogen atom number 1, and 2 shared between the oxygen atom and hydrogen atom number 2, and the other 6 non-shared electrons from the oxygen atom. So this water molecule is electrically neutral, but it has a partial positive side, the hydrogen side, and a partial negative side, the oxygen side of the molecule. The electrons are not shared equally within the molecule, as they have a higher probability of being found closer to the nucleus of the oxygen atom, giving that end a slightly negative charge. So the hydrogen atom's end of the molecule will have a slightly positive charge. These charged ends weakly attach the positive end of one water molecule to the negative end of an adjacent water molecule. When water is in liquid form, there are a few hydrogen bonds, solid form, many hydrogen bonds, and when water is steam or gas, there are no bonds because the molecules are too far apart to form any bonds. Hydrogen bonds only form between hydrogen atoms that are covalently bonded to an oxygen, nitrogen, or fluorine atom. Hydrogen bonds are also important in the structure of proteins and nucleic acids, which we will cover in later videos. So now we know that water molecules are polar, or have a slightly positive and slightly negative end. And in fact, many lipids, or fats and oils, are not polar, so their molecules share electrons equally in their bonds. So these are non-polar molecules. This means that when water and oil come together, they do not form bonds with one another. Even when we try to mix them, the water molecules will eventually separate because their polar molecules are attracted to one another and will form hydrogen bonds, which will separate the water and the non-polar oil molecules.
Now, when polar molecules are near each other, a van der Waals force of attraction between the molecules occurs because of their oppositely charged poles. In this example, the attraction of a polar molecule's negative pole to the positive pole around hydrogen atoms in water is a particularly strong type of van der Waals force called a hydrogen bond. Hydrogen bonds only occur in polar molecules between hydrogen in one molecule and oxygen, nitrogen, and fluorine